Go to the next one. It says MO and QO segments are congruent. Oh, write down given. So now you have to sit there and think about what can you do. Well, a lot of you guys yesterday, as I was helping people out throughout the day, fell into the pit of MQ being congruent to MQ. That's fine, but it doesn't get you anywhere between the two triangles. So at this point, what I would always recommend that you do is take 2 seconds and kind of highlight what triangles you're working with. What ones are you trying to show? You have to look at something dealing with MON and what was it, QOP. I look at those two. Take my pencil and just kind of darken those lines out a little bit. Or if you've got a highlighter, highlight over it. That way you're able to visualize better what you're trying to look at. Because sometimes in pictures, you're going to be given more information than you need. A distractor, if you will. Okay? Now, when I do that, I look back at my progression sheet, and there should be a picture that looks somewhat similar to what I just have highlighted. The bow tie, very good. The bow tie. So you're saying yes to what? Excellent. Vertical angles. So now you have vertical angles. Now, hopefully you wrote it out with the lettering being correct. If I do angle, guys, MON, the angles have to match up to being angle QOP. Vertical angles are congruent. Do you now have triangles? Because of? Well, how many? Let's see what you have. Hey! It's like you knew that I had that poster. Whatever. Look, he's wearing the thing I have hanging on the wall. We should tape him to the wall. But mine is the original. Yours is a reprint. As you can see, that's a little like waterlogged, and it's probably been out in the garage. I've had it forever. I don't remember when I got it, but I've had it for a long time. Yeah, that's it. That's it right there. Time stamp and everything. Yeah. Oh yeah? How did you not see that? Yeah, Michael Jordan one's been up there. I think I've had that thing at least since I've been teaching. I know I had it in my house somewhere. I don't remember where I had it. 13 years. It's been in my classroom for 13 years. I've got a pair of boots that are older than me. My old Doc Martens. Oh yeah, I got a pair of Doc Martens that are like from the early 90s that I still wear from time to time. The bottoms are all flat. They're awesome. Super comfortable. Anyway, we have angle sides. We just write it out. I wouldn't buy a pair of Doc Martens nowadays. They're not made to the same standards they used to be. But that's just me. So I have Perkins socks as well. I think I just keep my camera. Okay. Hey, look at that. 4 steps. Woohoo! Super easy. Okay. I know I got a lot of random stuff. All right, a lot of randomness. Okay, let me steal your straw picture if you don't mind. So next one. Rated drawing. gentlemen. Mental note. Next time I give you guys all these proofs like this, try to stay away from the H's and G's and J's and all that. ABCs and XYZs is probably a lot easier. Okay. So you're given that information. And the one thing that's new is the parallel. So we'll do that one in a second. Angles F, J, G is congruent to angle H, G, J. So you follow around. F, J, G is this guy. H, G, J is that one. Mark our diagrams first. Go to the next one. You got your parallels, F, G, and J, H. I think the diagram already had the arrows on it. But yesterday I told you guys to do what? Z. Draw a Z over it. Highlight that you have a Z. Okay? By doing that, we now know where the angles are because the sides change direction. Where the Z changes direction becomes the angles that are congruent to each other because of alternate interior angles. Okay? So by doing it this way, you can now mark up those two. And you write down FGJ is congruent to, I forgot to give it. I'm sorry, that's twice I did this. I'm sorry. FGJ would be congruent to HJG. And now that new reason. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. So those guys were out yesterday. We did two versions of parallel lines. One of them looked like a Z, either forwards or backwards. And then if it was turned sideways, it was an N, forwards or backwards. And anywhere that those values changed direction, where the Z changes direction, those angles were always alternate interior. And we had to write it out with that symbol. Sorry. Okay? Now you look at your diagram, and you remember yesterday on the progression sheet, what else did I say about when you make the Z? Exactly. There's a reflexive property hiding in the Z. So we know that GJ is congruent to GJ, or JG, however you want to write it. There's your reflex property. And now, how are your triangles congruent according to your picture? Excellent, excellent, excellent. Not terrible, is it? I hope. Yeah. Well, now pretty easy. Yeah. Well, yeah. Anything that you first learn sucks, but as you do more of it, it gets easier. I hope. Okay. Third one. no. What do you do to start? I have forgotten. I don't remember. FG is parallel to KL. This time I'm going to write down the word given. Draw my arrows, and then I'm going to trace my Z. I have now traced my Z, which means where it changes direction are the alternate interior angles. So just mark them and write them down. As you trace it, you then know what they have to be. We know now angle GFK is congruent to angle LKF because if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Ew. There's what? Yeah, I haven't marked it yet. It was they already did that. Okay. Yes, ma'am. Shh, ladies. Don't copy on this. All right. Now I go to the next one. FG and KL are congruent. By them being parallel doesn't necessarily mean that they're going to be congruent unless it's given to you. Okay, you can't just assume that parallel congruencies go hand in hand. And what's the last thing I got to do? Reflex it. Very good. KF congruent to KF. And now you wind up with which of the four? Very good. Side angle side. Quick 5 steps. Given, progression, given, reflexive, and you're done. I think I already said this. Quiz tomorrow, all you really need is, there won't be any algebra ones, it's just progression sheet. Everything will be on your own. You'll fill in the blanks. Okay, so I'll be right there. This is of the complexity that we're doing. Okay, this is the complexities we're doing. I don't know if you noticed this. Hey, guys, enough. I can go get the quiz right now if you want. Once again, you start with the parallel. When you start with the parallel, what should you do to your diagram? Mark it. Make your Z. That gives you your angles. Draw the Z, fill it in. Draw the Z, fill it in. It's pretty much the same thing over and over and over again, right? A, B, C, D, F, G, H. Oh, excuse me. Oh no, what did I have left to do? I don't know if you guys noticed this, but this is the exact same proof as the one before. Make sure you're writing reflexive property. You guys notice those two are the exact same thing? Yeah. So the same setups, guys. You'll see this a lot. You'll see this a lot as you go through. There's only so many proofs that we can do. There's only so many styles that you guys are able to walk yourselves through without too much of a hassle, to be honest with you. And this style from parallel shows up pretty regular. Okay? Super common. Yes, ma'am. No, not always. Remember the one that we did that was also parallel just before that, where it was a side angle? It depends on how it's used. Okay. I've also seen, I know that this one will happen sometimes. Obviously, it's not on your sheet right now, and we'll come back to this here in a second. I have seen ones that look like this. Oops. Where you're given that, where you're given something like this. And you've got your two diagonals. You have two sets. And this is where it just gets kind of messy. If you trace one, you get this one here and here. You okay with that? But then if you trace the other, you get here, here. So it can get into other versions of it depending upon what you're looking for and all that. So it'll show up. It does. I don't think we have one like. I know we don't have one like that tomorrow, but you can get other parallels. Yes, sir. I don't. We know we had a bird hit the window. I don't know. It might have been in the other class. It might have been in Miss Miller's class. I think I remember. I vaguely remember now. She said that something hit the window. Obviously, we weren't in here, but I think that's what it was. I'll ask her and double check. I just noticed that too. She just said upset. All because we're all staring at the Michael Jordan poster from forever ago. Anyway, good times. And that was all of those, right? All right. Do me a favor then. Take a couple of minutes, and I want you guys to do number 4. Do number 4 real quick. Is this Steve the right angle? Where's the right angle? Okay, write it down. How many letters do you need for right angle? 3. See. Okay. Yep. Either one. All right. Let's continue on. Do that third one. I'll draw it up here, and we'll go over here in a second. Why are you so angry at those? A and B. Is C up on the top? D, then C here? Yeah. Thank you. Yeah, I'm just going to fill them all in. Ladies and gentlemen, you should be working. Thank you. So it kind of looks like that. Remember, when you're doing a progression through like a little bit, so we have a little bit of space. Same thing with this stuff, because this is one of those that just gives you a boatload of information. It's a super easy one. It just got a lot of info. I mean, really, as you go through it, you've got AB is perpendicular to CM, given. I saw that a lot of you guys, what you did is you put your first two givens together, and then you said you labeled the two right angles after that. That's fine. No big deal. But in my head, once I have perpendicular, I'm going to go ahead and figure out, all right, that means that I have the right angle here. So I'm just going to say angle AMC is a right angle. Definition of perpendicular. Then I go to the next one. AB is also perpendicular to DB, given. That means that angle MBD is a right angle. And some of you guys shorten this and combine them into different things. And from what I've seen, most people are okay. Yes, ma'am. You have to say that they're right angles, even though it was marked in the diagram. So now you have your two right angles, and you say that they're equal. Then you say that they're congruent. That's one downfall about pictures that are already marked, is you guys have a hard time of deciphering what's going on. All right angles congruent. Then you had DB and CM. And then you had midpoint of AM. Oh, it's AB, wasn't it? Sorry, AB. That gives you AM and MB. And as you go back up here, I know this is a lot for this one, but really, this is one of those examples that as long as you have a progression sheet, there's no thinking. You didn't have to think about a single thing on there. All right, sorry. The only thing you had to think about, which way the letters go. That's really it on that. Because you have all the info given to you. You have the progressions that tell you what to do when you've got those perpendiculars or when you've got those midpoints and so on. So now you just got now you're done with your triangles. It's not going to kill you. Put it in the pocket. Guys, the phone thing is just really getting out of hand. You guys are screwed. I'm testing some quizzes. I'm telling you, you're just gonna shoot yourselves in the foot. Okay? And then you just go ahead and you're done with side angle side for triangles. AMC. Okay. There's one more one. Let me show you here. Okay, before you can do this, let's see if that's real fast. You gotta say this here. Now you. Yeah, but here, AB and CM, that's just these two. It's usually only one angle. And then you've got AB, DB, that's the other angle. So if you set these two first, then you can just break that. All right.
That's why you do them separately.
Yes. But if you put them ahead, it's not difficult. So that's 1, 2, 3. That was number 4, right? 6. Do 6 real quick. Do 6. Now, one of the things that I want to make sure you guys have on there, on the pressure sheet deals with segment bisectors. So just double check, make sure you have segment bisector on there. I know we have angle bisector. Almost forgot about it. Thank you, what we got? What do segment bisectors do? That's one thing. Second. So if you have a second bisector, then you've got two segments that are equal to each other, congruent to each other, right? So what's weird with this one is that you have to follow through and look at, you're starting with the two larger segments, AE and BB. If those two bisect each other, at what point do those two segments run into each other? At C, okay? So if I'm just given that amount right there, does it say that AE and segment BD, does it say that they're equal to each other anywhere? So I don't know that all 4 of these pieces are going to be the same, but what I do know for certain is that I can do this. Does that make sense? So again, this is that same basic principle that you're given one bit of information, AE and BD bisect each other, because you're given. Then when you have a segment bisector, that means you set segments congruent to segments. So you just have to do that twice. Yes, sir. Correct. Because when something gets bisected, it means it's cut in half into 2 congruent parts. Yes, sir. Yep. That's what a segment bisector is. Just like an angle bisector. Angle bisector cuts an angle into 2 equal parts. Yes, sir. And I was just about to write that. I would say AC congruent CE, definition, segment, bisector. And then I would do another one. DC congruent to CB, definition, segment, bisector. Now there should be a glaringly obvious next step. What is it? It is. Say with conviction. Trust yourself, man. Don't be so passive. Say vertical. Like you're angry. Like you're really, really mad. Someone stole your lunch money. Somebody stepped on your white shoes. You dropped your pencil. So you're saying angle ACE. Watch where you went with your tick marks. ACB. Oh, you said ACE. That's a straight angle. That's not going to work. Yeah. So it's going to go ACB. If I went A, it's going to go E to D. Follow your tick marks. And then if you see vertical lines are congruent. which therefore means you are basically done because what do you have in front of you? You have triangles, which I don't remember how it was said in the proof, but I know if I say triangle ACB, it has to be congruent to triangle ECD because of side angle side. Okay. As of right now, there are only 2 left on this sheet. And I also want you to do, I think it's page 288. I got to double check my notes. Numbers 13 and 14. I'll collect that tomorrow prior to the quiz. You might have space on the sheet to do that. Otherwise, just staple the sheet of paper to it. Let me double check if that is the correct page. I believe so. But you know me, never made a mistake in my life. 277. I think I was wrong. All right, so like I said, it's on page 277. We'll have our quiz tomorrow. Monday, we will do a little refresher after the weekend on how you set stuff up, just giving pictures and small bits of info, how you can start thinking ahead onto how you're going to prove something. And then Tuesday, we'll start corresponding parts.
So I'm kind of also figure out how do you know
What's the tick mark? The side of the A?
the tick mark is the side.
Or it could be an angle. Remember, sides are on the edges, angles are in between. That's all it is. You count what you have. Here you've got 2 angles and a side after it. 2 angles, a side in between. 2 sides, angle in between. All 3 sides. That's what you're looking for. That's what you're looking for in those pictures. Yes, ma'am. Yeah. No alpha between alpha stuff. Just triangle stuff. When we get to it, yeah. I haven't thought that far ahead. The test on all this stuff probably won't be till that Wednesday before conferences. So we got a little bit of time still. We still have chapter 4 actually takes a long time to get through. No worries. So we'll have, because next week we have 4.5 days. We've got the half day on Friday. And the following week we've got 3.5 days because of conferences. So you throw in a little bit of review here and there. It's about 4 sections-ish, 3 sections left to go. And they have corresponding parts takes the longest. Then we got to do isosceles, equilateral. And that's, I don't think I'm going to do any proof with that. It'll probably just be a lot of algebra. But if we do proof on that, it's pretty easy.